Namaskar. Welcome to the Chemical Kinetics class. In this class, we will discuss rate law and factors affecting rate of the reaction. First of all, we will discuss rate law or rate equation. Dear students, we know that each chemical reaction has its own equation that relates rate of reaction with concentration of reactants. So, rate law is a mathematical expression that showing the relationship between the reaction rate and the concentration of reactants. This is rate law for the reaction that involve reactant A and B. Dear students, some points to be remembered about rate law or rate equation. First is, in rate law or rate equation, the overall concentration dependence of reaction rate is given. And second is, rate laws are mathematically descriptions of experimentally verifiable data. So, rate law or rate equation is determined experimentally. For the establishment of rate of reaction and concentration of reactants, we will discuss law of mass action. The law of mass action first time proposed by Goldberg and Vage in 1867, and it states that the rate of a chemical reaction is directly proportional to the product of active masses or molar concentrations of reactants. Here we consider this reaction. The left part of the reaction represents reactants and right parts of the reaction represents products. For this reaction, according to law of mass action, rate is directly proportional to concentration of reactant A and concentration of reactant B. Here, if we remove proportionality sign, then this equation becomes rate equals to K into concentration of reactant A to the power of N and concentration of reactant B to the power of M. Here A and B represents reactant concentrations, exponent N and M represents order of the reaction, K is rate constant and sometimes known as velocity constant or velocity coefficient, and summation of N and M represent overall order of the reaction. Here we will discuss a specific rate constant. For this purpose, we consider this rate law. If concentration of reactant A and B is unity, then rate becomes equals to K. That means rate becomes to rate constant, and now rate constant is known as specific rate constant. There are some points to be remembered about specific rate constant. First is, a specific rate constant of a reaction may be defined as the rate of reaction when the concentration of each of the reactants is unity at a given temperature. That means rate constant is also depends on temperature. The specific rate constant K is the proportionality constant relating the rate of the reaction and the concentration of reactants. Third point is, the rate law and the specific rate constant for any chemical reaction must be determined experimentally. Fourth point is, the value of the rate constant is temperature dependent, and last point is a large value of rate constant means that the rate is relatively fast, while a small value of the rate constant means that the reaction is relatively slow. Now, there are the factors these influence rate of the reaction. First is temperature. Dear students, it has been observed that rate of the reaction increases with the rise in temperature of the reaction, and it is also observed that rate constant is approximately double with the 10 degrees centigrade rise in reaction temperature. This can be explained by two theories. First is collision theory. According to this theory, when two chemicals react, their molecules have to collide with each other in a particular orientation with sufficient energy for the reaction to take place. So, if we rise temperature, collisions in between reactant molecules also increases and rate of reaction also increases. Second theory is kinetic theory. Kinetic theory deals with the kinetic energy of reactant molecules. If we rise in temperature, then kinetic energy of the reactant molecules also increases. So, molecules move faster and reaction becomes also faster. Second factor is concentration of reactants. As the concentration of reactants increases, rate of reaction also increases because rate of the reaction directly proportional to concentration of reactants. The third factor is catalyst. Catalyst provides alternate path of low activation energy for the reaction to take place. So, catalysts speed up the reactions by lowering activation energy. The effect of catalyst on reaction rates will be more discussed in next part. The fourth factor is surface area of solid reactants. Reaction rates also depends on surface area of reactant molecules. If it increases surface area of reactants, then the speed of the reaction also increases. So, generally we use powder form of the reactants in reactions. Fifth factor is pressure of the gaseous reactants or products. If we increase pressure of the reactants, then volume will decrease and consequently concentration of the reactants increases. So, rate of the reaction increases. Sixth and last factor is sunlight. Dear students, some chemical reactions takes place in the presence of sunlight. These reactions called photochemical reactions. For example, photosynthesis. Photochemical reactions must be required presence of sunlight. In the absence of sunlight, these reactions do not take place.